Guys, today I'll be attempting to solve leetcode 11, which is container with most water. So the problem that we've been given is that there's an array which contains heights. So the heights of these bars are basically represented in the array, and we've got to find a container for water which will contain the maximum volume of water. So we do this by calculating the area of the maximum rectangle enclosed between the two greatest heights present in the height column or some in the height array, and not necessarily two greatest heights, the two heights which can be enclosed within two vertical bars. So if you can see in the diagram, although the greatest height is 8 and the second greatest height is 7, there is no combination of 7 and 8 which gives us 56 to solve the problem. So we need to optimize the solution to find the maximum area. We've also been given that uh, our constraint needs to fall within these ranges, and I think that's appropriate for the problem. So the first solution which comes to my mind is a brute force solution. So if I take the first height, right? So if I can just annotate, yeah. If I take the first height given to me and I calculate the maximum area between this height and the height next to it, I'd get this area, which is a 1 by 1 rectangle. Now, obviously, I'll store this to check if this value is the greatest between all the possible areas that I can find within this diagram. So I'll go here next. I'll draw this line with this and this, right? So I have an area of 2. This is the width of 2, and this is the height of 1. This is the area of 2. So I'll store this next in max, and then I'll check this, which is the area of, this is width 3 and height 1. So area is 3, and so on and so forth. I think you get the pattern. Go here, I'll go here, I'll go here. So the binding is on the height of the first block we choose, right? So if we shift to over here, this the second one, right? So if we compare this with this, the height will be the maximum height of the rectangle would be this, right? In this case, it is 6, and the width is 1. So our area is 6, right? And so on and so forth. So if we compare this one with this one, it'll go here, right? So the height is 2 in this case, and the width is again 2, so it's 4 again. And then we compare this, and then while doing this, we eventually find our most optimal solution, which is the maximum area which we can have, which is between the two red bars given to us. So this and this. And this area would be 7 times the width, in this case is 1, 2, 3, 4, 5, 6, 7. So we have 49 is the maximum area which we can form, which is the output given to us. So I'll try and code this the brute force way, just to give you a sense of how it works. And then I'll probably show you the most optimal solution of the problem. So while doing the brute force method, we need to store the result, right? So let me just say the value equals 0 initially. And we need to define bounds for our lengths and widths. So in that sense, I will have a double for loop to kind of iterate over both of them. So let's say for length, let's say in range. Now we have our array defined as height. So we take the len of height, right? And while this is true, we again traverse for, let's say, width. So for width in range, now we need to make sure that the width is one ahead of the height always, because we're always going one ahead and one ahead, obviously, to find all the possible combinations. So we can write length plus 1 and len of height, right? So when that is true, I'll calculate my area, which I represent by area rectangle, is equal to, now the area was width into height. So in this case, I'll have to subtract my rightmost column with my leftmost bar. So I have this and this and this. Okay, so I find my area with respect to this, the width, because right will always be more than left in terms of the way we kind of write our coordinates. So that's our first category. So we do that and we multiply that with Now we need, as we saw in our examples also, there is a minimum bound which is present. In this case, no matter how long this is, right? So if this might even go to infinity. But if my first height is one, the maximum area which we can have is one by one. Because if we store water, which is more than which is height of more than one, it'll kind of overflow. So we need to make sure it's contained within this small rectangle. So it's obviously the minimum of the height of which we have, height of the width which we have, right? Yep, that should be it. And we store in value the maximum, obviously, because we want the maximum area which we kind of need for this problem. So we store the maximum of the value and the area of the rectangle which we have. And of course, after this, we return uh, value. But yeah, and this should be it, I guess, because we found the value, which is the maximum of the value and the area we calculate in each iteration. So if we try and run this, uh, let's see what happens, because this is a time complexity of, okay, wait, I did something. Okay, sorry, this should be length minus. Uh, okay, it got accepted, but it's still O of n squared. If I submit this, um, probably I might get something uh, which should not be as optimal as I wanted it to be. So we'll wait for the result. Okay, that's kind of weird. So this is the brute force solution. I had one more solution with this. Okay, yeah, got it. So it shows time limit exceeded because this is of n squared. So we obviously want this to have just one while or one for loop to work with. So let's run that, and let's code a more efficient solution. So if I think of it right, we need to do two things in this case. We can have two pointers to work with basically. So we have a left pointer and a right pointer. Let's say our left pointer would point here, right? This is a left pointer, this is a right pointer. And we need to find two bars of maximum length to work with. In this case, if in the problem given to us, if we shift a left pointer by one here and decrement a right pointer by one here, or like sorry, we let a right pointer be as it is, we kind of get that this area would work out for us, right? So we need to make sure that we shift our pointers accordingly to get our optimal solution. Now, in this case, if we intend to do so, we need to have two constraints. Firstly, a left pointer we cannot get more than a right pointer. So if, let's say, we happen to move all the way down here and it kind of reaches a right pointer here, we can't have an area of zero, right? Eventually. So we have to have a condition where a left pointer should always be less than a right pointer. And when that is true, we need to always again make sure that the height of the left, okay, when we have two more conditions, that the height of the left one should always be less than the height of right one. If that is true, we shift our left pointer one, right? So if left is more than height, sorry, if right is more than left, we shift our pointer one here because we need to kind of get the maximum area. So as an example, if our right is more than our left, let's say this one, right? This is obviously more than our left over here. So we shift this over here because we want to find the area with the maximum height that we can have. So that would be one condition. And obviously, if the left is more than the right, suppose this is the left one compared to this right, when this happens, we shift our pointer one back. So our right pointer goes one behind because we need to find a bar with a greater height compared to the previous one for a combination to work out. So these are the four conditions that we have. And if I intend to make this work, then I would need to store a value. So if I have value, let's say 0 here, I will store my left and right pointers. So let's say left and right, 0 here, right? And we can also, because our right pointer needs to be the rightmost pointer in the entire diagram. So it would read as len of height, right, minus minus 1. The semicolon doesn't go away, I guess. Yeah, and when we need to have a condition here, as I said, when left is while left is less than right, when that is true, we need to make sure that we find our area. So I have an area formula here. I'll use that, which is this, and we will calculate the result again, which is the maximum of the result and the area of the rectangle, right? And our condition again. So if our height of left happens to be less than the height of the right, that is true, then we don't need the brackets. I'm sorry for that. Yep. When that is true, then we increment a left pointer by 1, because if our height is more on the right, we need to make sure we get the greater height, right? Left would be plus left is plus equal 1. Else we need to make sure that we have right minus equal to 1, which is the other case. When our left is more than our right, we need to make sure our pointer points towards the greater height, which is the left one. So once we've done this, we return the result which we have, which is value. We need to see if this works or not. It should work. Okay. Oh, I missed a colon. Sorry for that. Syntax errors happen always. So okay, we didn't define with an length. We could because yeah, we can have right and left. Sorry, we can have right and left. Right should always more than left. So that's the while statement we have here. So it's on basis of this, right? We read this, and okay, we haven't defined length here. So let's say this left doesn't matter which combination we take, because we're eventually finding the minimum between height of left and height of right. So we take those two to find the area. And okay, which is an indentation issue. It's okay, something didn't match. This one way. I don't know whether that's the case, because I did have this right, and it kind of matches. Result. Okay, yeah, we had sorry. This should be value, return value at the end too. Yep, this works. And if we submit this and see what happens eventually, we will get that yep, it accepted, and yep, it has good memory and good runtime. So this should be the solution for this problem. And thank you for tuning in and listening to me. Thank you.